Hello, in this session we are going to derive the quadratic formula by the method of completing the square. Welcome. The expression given is ax squared plus bx plus c. Now this expression is a standard quadratic equation. In this equation, a is the coefficient of x squared, b is the coefficient of x, and c is a constant term. In order to complete the square, the first rule is that the coefficient of x squared has to be a unit. In other words, 1. So we need to simply reduce it by dividing all the terms by a, such that a and a cancels, so that we have 1 as a coefficient of x squared. That reduces our expression into the form x squared plus b over ax plus c over a is 0. The next step after reducing the coefficient of x squared into a unit is to transfer the constant term to the right hand side. In this respect, we are going to take x squared plus b over ax. We move this to the right hand side, so it becomes equals to minus c over a. The next step after moving the constant term to the right hand side is to introduce a new c, and the new c is obtained by the formula b over 2 into bracket squared. Now, given that our b term is b over a, we proceed by saying that c is going to be b over a divided by 2, simply because b over 2 is the same as b divided by 2, and our b in this case is b over a. Now this translates into b all over 2a into bracket squared. So we have found our new c as b over 2a squared. The next step is to introduce the new c in the expression. The previous expression was simply x squared plus b over a x. Now introducing the new c, which is a b over 2a squared on the left hand side, and proceeded to do so on the right hand side as well. So this will lead to an expression of this form, equivalent to minus c over a plus b over 2a into bracket squared. So we have successfully introduced the new c on both sides of the quadratic expression. What is the next step? The next step would be to simplify the expression on the right hand side. On the right hand side, when you open the brackets, you will find that this is equivalent to c minus c over a plus b squared all over 4a squared. Now, given that is the expression on the right hand side, we are now going to finalize the expression by simplifying the property of a and 4a squared. That will give us roughly, if I use this space here, the LCM of a and 4a squared is 4a squared. Now, using that LCM, we find that a goes into 4a squared 4a times. So 4a times minus c is the same as minus 4ac. And then 4a squared goes into 4a squared 1 time. So it gives us plus b squared. So the right hand expression of the quadratic expression has been reduced into minus 4ac plus b squared over 4a. The next thing is to represent the left and right expression as a complete expression, and in this respect we'll end up having x squared plus b over ax plus b over 2a into bracket squared is equivalent to the right hand expression, which in this case has been found as minus 4ac, as you can see here, minus 4ac plus b squared over 4a. So that is the same as b squared minus 4ac all over 4a squared. That done moves us to the next step. What is the next step? The next step is to use the quadratic identity. And in every quadratic identity, we assume that the left-hand expression could be reduced simply into x plus b over 2a into bracket squared. And this will be equivalent to what's on the right, which is b squared minus 4ac all over 4a squared. How then do we make x the subject of this expression? To make x the subject of this expression, we are going to proceed by introducing a square root sign on both sides of the expression. And in so doing, we find that on the left, the square and the square root sign will cancel out, leaving us with x plus b all over 2a is equivalent to the right hand side. Now on the right hand side, that square root sign is going to reduce into the form of square root of b squared minus 4ac. Following the Bodmer's formula, we cannot simplify the square root of b squared simply because the square root extends where there is a negative sign. However, the denominator has a square root equivalent to 2a. That one has substantially reduced our expression to a form which is easier to simplify. We proceed to the next step. In the next step, we are going to move the expression b over 2a, this expression b over 2a, to the right hand side. In this case, we have x is equivalent to minus b all over 2a, and then plus square root of b squared minus 4ac all over 2a. The next step is simply to harmonize the right hand side. Harmonizing the right hand side, we use the same LCM, so we have x is the same as LCM is 2a. 2a goes into 2a one time, so we have minus b. The square root of any number gives us a solution which is positive or negative, and therefore we have the square root of b squared minus 4ac. And you can see clearly that we have successfully derived the quadratic formula using the method of completing the square. And this formula is, as you can see here, if I can demarcate it with that bracket in red, you can see that x is equivalent to minus b plus or minus the root of b squared minus 4ac all over 2a, which represents the quadratic formula. What have we said? To be able to derive, to complete the square or derive the quadratic formula using the method of completing the square, the first rule of completing the square is making the coefficient of x squared unit or a unit. That's why we're dividing by a. And once we do that, the second step is to move the constant term to the right hand side, which we did, and we got it as minus c over a. The third step is that of introducing a new c, and a new c is represented by b over 2 into bracket squared. B in this case is the coefficient of x squared. In our case, the coefficient of x squared was found to be b over a. So we took b over a divided by 2 into bracket squared, which translated into b over 2a into bracket squared. The fourth step is introducing the new c on both sides of the equation, and when we did that, we were able to relate the expression as plus b over 2a squared on the left and plus b over 2 squared on the right hand side. And then we proceeded to simplify that, and the simplified form gave us an expression of the form ax squared plus b over ax plus b over 2a into bracket squared equal to b squared minus 4ac over 4a squared. And then the fifth step is simply to eliminate the powers. And to eliminate the powers, we were able to use the quadratic identity, which gave us power 2, and then we introduced the two square root signs on both sides, which reduced us into x plus b over 2a is equivalent to b squared minus 4ac over 2a. The final step, which is step 6, is simply to make x the subject by moving the term b over 2a, and when we did that, we were able to get minus b over 2a plus root of b squared minus 4ac over 2a. And the final step, which is the seventh step, is simply to integrate the right side of the expression by using the common denominator, or LCM, in this case 2a. And that gives us the quadratic formula, which is x is equals to minus b plus or minus the root of b squared minus 4ac over 2a. In our next expression, we are going to use articulately this quadratic formula to solve quadratic expression and find other means of solving quadratic expressions or equations using other methods alongside the completing square. Thank you.